Thank you everyone for clicking into our video for subject SKD 2001-3 Database Management System. We're from Group 7 and this video is going to be talking about our project, namely Amaze Cleaning System, ACS for short. So the team members for this project is Chong Kar Min 287173, Tracy Liaw 287944, and Wei Jie 289669. In this video, we're going to be talking about Enhanced Entity Relational Diagram, ER for short, Relational Model, Normalization, as well as the demonstration for database system. So I'll be starting off by explaining the ER diagram for our project. There's a total of 8 entities, and the first entity is customer, where the primary key is customer ID. The other attributes include customer name, customer IC, customer phone number, customer address, customer gender, and customer email. The second entity is cleaner. The primary key for cleaner is cleaner ID. The other attributes include cleaner name, cleaner IC, cleaner phone number, cleaner gender, cleaner location, cleaner email, cleaner year experience. The third entity and fourth entity are customer feedback and cleaner feedback, where the primary key for these two entities are customer feedback ID and cleaner feedback ID. They also have attributes such as customer rating, customer comments, or cleaner rating and cleaner comment. The fifth entity is payment. The primary key for payment is payment ID. The other attributes include payment date, working duration, payment amount, and payment method. The sixth entity is cleaning service. The primary key for this entity is service ID. Other attributes include price and description. The seventh entity is house, where the attribute is number of room, and the eighth entity is office, where the attribute is number of floors. I'll start off by explaining from the first entity, that is customer. So one customer can give one or many customer feedback, while one feedback is only given from one customer. Next, customer can also make one or many payments, while one payment is only made from one customer. On the other hand, one cleaner leaves one or many cleaner feedback, while one feedback only comes from one cleaner. One cleaner can also receive one or many payments, but one payment is only received by one cleaner. Not only that, one cleaner also provides one or many cleaning service. Cleaning service is a superclass of house or office. The constraints are mandatory or, where in this case, customer must choose either house service or office service while making a payment. Lastly, each payment has only one customer feedback, one cleaner feedback, and one cleaning service, and it has an aggregation relationship.
Thank you, Tracy. My name is Chong Kar Min, number matric 287173. Now I will present about the relational model and the normalization of our database system. First, relational model represents the database as a collection of relations. In here, we state out all the relation name along with the attributes based on the ER diagram. First, customer. Customer has cast ID, cast name, cast IC, cast phone number, cast address, cast gender, and cast email. Its primary key is cast ID. For the second one is cleaner. Cleaner has cleaner ID, cleaner name, cleaner IC, cleaner phone number, cleaner gender, cleaner location, cleaner email, and cleaner year experience. The primary key is cleaner ID. For the third one is cast feedback. Cast feedback has cast feedback ID, cast rating, and cast comment. Its primary key is cast feedback ID. Since there is a one-to-many relationship between customer and cast feedback, therefore cast feedback will take the cast ID from the customer as its foreign key. For the fourth one is cleaner feedback. Cleaner feedback has cleaner feedback ID, cleaner rating, and cleaner comment. Its primary key is cleaner feedback ID. Since there is a one-to-many relationship between the cleaner and cleaner feedback, therefore cleaner feedback will take the cleaner ID from the cleaner as its foreign key. Next, house and office are the subclasses of the superclass, which is cleaning service. They have the participation constraint and disjoint constraints, which is mandatory or. Therefore, house and office will take the attributes from the cleaning service, which are service ID, price, and description combined with its own attribute, which is number of room for the house and number of floor for the office. Then they set the service ID as their primary key. Since there is also one-to-many relationship with the cleaner and cleaning service, therefore both house and office will take the cleaner ID from the cleaner as their foreign key. Lastly, for the payment has the attributes of payment ID, which is the primary key, payment date, working duration, payment amount, and payment method. Since there are one-to-many relationships between the customer and the payment, and also cleaner and the payment, therefore payment will take the cash ID from the customer and cleaner ID from the cleaner as its foreign keys. Moreover, there is also aggregation between the payment with the cleaning service, cash feedback, and cleaner feedback. Thus, payment also will take the service ID from house and office, cash feedback ID from the cash feedback, and cleaner feedback ID from the cleaner feedback as its own foreign key. Now I will continue with the normalization. For the unnormalized form, UNF, we transform all the attributes from the information source, which is our ER diagram, as the name of cleaning system. Next, for the first normal form 1NF, we will remove the repeating group and nominate an attribute or a group of attributes to act as the key for the unnormalized table. We identify cash ID and cleaner ID as the primary key of the cleaning system. For the second normal form 2NF, we will identify primary key for the first NF relation, identify functional dependency in the relation. If partial dependency exists on the primary key, we will remove them by placing them in a new relation along with the copy of their determinant. In here, we set the cash ID as the primary key and take out the cash name, cash IC, cash phone number, cash address, cash gender, and cash email from the cleaning system to a new relation name with customer. Moreover, we also set the cleaner ID as the primary key and take out cleaner name, cleaner IC, cleaner phone number, cleaner gender, cleaner location, cleaner email, and cleaner year experience from the cleaning system to a new relation name with cleaner. For the third normal form 3NF, we will identify the primary key in the second normal form relation. Identify the functional dependencies in the relation. If transitive dependency exists on the primary key, we will remove them by placing them in a new relation along with the copy of their determinant. In here, we copy back the relation of customer and cleaner from the second normal form just now. Then, we set the cash feedback ID as the primary key, cash ID from the customer as the foreign key, and remove the cash rating and cash comment from the cleaning system to a new relation name with cash feedback. Besides that, we set cleaner feedback ID as the primary key, cleaner ID from the cleaner as the foreign key, and remove the cleaner rating and cleaner comment from the cleaning system to a new relation name with cleaner feedback. Apart from that, we also set payment ID as the primary key and remove the payment date, working duration, payment amount, and payment method from the cleaning system to a new relation name with payment. Then, we set the service ID as the primary keys for the house service and office service. We remove the price, description, and number of rooms from the cleaning system to a new relation name with the house service. Then, we remove the number of floors from the cleaning system to a new relation name with office service. Lastly, for the cleaning system, we remain the primary key of cash ID and cleaner ID and set payment ID, service ID, cash feedback ID, and cleaner feedback ID as its foreign key to link with the other relations. That's all from me. I will pass it to Wei Jie.
Good day, madam. My name is Wei Jie with matrix number 28969. Today I'm gonna show the database part of our cleaning system. The database system is built according to the normalization using the SQL language. Therefore, there will be total of 8 tables. The tools that we use to build our database is using the MySQL workbench. So inside the MySQL workbench, you can actually build up your own servers by clicking on the addition buttons here and type in the server name. So I will just use the one that I have created. So you have to enter your own password. So inside your database servers, you can actually build up your own database page. Like example, you can click on the scheme button here to create your own scheme. So for example, if I want to create a scheme for my cleaning system, you can type in the scheme name and also click on the apply button. after the scheme is successfully created, you can start creating the table. So first, you have to make sure the scheme that you created is set to the default scheme, and then the table can be created by two ways. One of it is by typing the SQL coding. So for example, if I want to create a table of name cleaner, so you can type create table and then followed by the column name, which is the column ID, and also the column type, and followed by whether you want to set it to not now or not, and then followed by the others columns. And at the same time, you can also set up your own primary key. By, for example, if I want to set up the cleaner ID as the primary key, so after that we can click on the query, execute. So it shows that the table is created. After the table is created, it will not directly show in the file at the left part, but we have to refresh the server first. And then it will be shown here. To show the foreign key part, we have to create another table. So for example, according to our normalization, a table that have the foreign key reference to the cleaner is the cleaner feedback. So we can type into our code, create a table of cleaner feedback name, and then the column name is cleaner feedback, and also their types, and followed by the primary key, which is the cleaner feedback ID, and also foreign key, which is the cleaner ID that reference to the cleaner tables of cleaner IDs. And also, if we want to set up the foreign key to be updated together, if we update at the cleaner tables, you can set it to be cascade type. So when we perform delete and update function in the cleaner, we will at the same time update at these tables. So we will start execute it. So it shows that the table is successfully created, and we have to refresh the server. Then both our tables is successfully created. Well, for the second method to create a table for this database system, you can actually click on the table and create it. So in here, we can actually type our table's name, for example, cleaner, and we can type in the column name, the ID, and which type is it. And at the same time, set up the primary key and also the foreign key, if any. So this is the alternative way to create a table for the database system without typing the code ourselves. And then I will show how to insert the data into our table that have created. For example, I want to enter the data into the cleaner table. I can type in the code something like this. The command is about the insert into, and then followed by the table name of what values. The values are actually followed by the column name at the cleaner table that we have picked. So for example, ID followed by the name, and also IC, and etc. So you have to make sure it's followed by the ID, the name, the IC, phone number, and so on. So after we have made sure that we want to insert is followed by the column name, we can click on the query and execute it. So it shows that the data is successfully inserted into the cleaner table, and we can see whether it is actually inserted or not. And here we can see the data is successfully inserted into the cleaner tables. However, in MySQL Workbench, it actually provides us an alternative way to import our data. So for example, you can click on the table function here, and then data table import. We can select our CSV file that has our own data. Like for example, if I want to clean up data, and we can use an existing table that we have created, or create a new one. We can type the name. So if you want to use the existing one, you have to make sure the column name is pointed to the correct data name. So for example, if I want the cleaner ID, it's showing the cleaner ID is in the cleaner ID column. So after we make sure every column is in the corresponding column, we can click on the next. And then it shows that the 15 records is imported into the data. And then we can view the cleaner tables, whether it's imported successfully or not. So inside the table, we can see the cleaner ID from B001 to B015 is successfully imported. So that's the principle I use to create the database for our Amaze clean system. So in the Amaze clean system, we have created 8 tables according to the normalizations, which each one will store a different data, and some will have the foreign key reference from the another tables. That's all about the database part. Thank you.
So that's all for our video today. Thank you.